Okay, our part 2 dealing with classification is how are organisms scientifically named. And this too was established by Linnaeus, and it was put in his first book, which was the book called Species Plantarum, that had to do with his plant classification. So it actually began then when that book was published in 1753. So that's when scientific naming began. Now, because it was done by Linnaeus, remember he did the classification orders. Remember the 7 in order? Kingdom, phylum, class, order, family, genus, species. Now, why do you think we need a scientific name? Well, many organisms have common names. Imagine if one organism had several common names, and so one scientist in one part of the world or one part of the country, let me give you an example, like gopher. Now, when you hear the word gopher, you have a certain picture of an animal. And it depends upon where you lived on what you called gopher. In some places, a gopher was a snake. So one scientist, you say gopher, they're going to think of a snake. One's a little animal, sort of like the woodchuck that we're going to see. And so they would think of that. Actually, gopher was also a common name for a type of snake, a type of turtle, and I forget how many different organisms. So it depended. So when all these scientists would use these common names, it would get very confusing to them. So they had to come up with some way that if we talk about an organism, every scientist, everybody all over would know what specific organism we're talking about. So that's why Linnaeus came up with a way to scientifically name the organism. Here's an example, and this is what I call a woodchuck, but not everybody does. There are people who refer to this organism here as a groundhog, and some of them call him a whistle pig because of the type of whistle that he makes. So that would be confusing. If a scientist says woodchuck, then another one wouldn't think of it because it's known as a whistle pig to him or her. This system of naming organisms is called binomial nomenclature. So make sure you know the title of it and what it means. So our system of naming organisms is known as binomial nomenclature. Now this is why they call it that. The actual word bi means two, nomial names. Nomenclature means naming. So it's a system by which we use to name organisms using two names. Now, in our system for humans, a lot of us have 3 names. But scientifically, all humans have the same name, Homo sapien. That is our one for human. So if you think about Linnaeus's classification system, and he wanted to use that to narrow it down to one particular type of organism, what 2 levels of classification would he choose? Kingdom, phylum, class, order, family, genus, or species. What would narrow it down? Well, remember, as you go down the scale, fewer and fewer organisms are in it because they have to have more characteristics alike. And then you finally get to the most well-defined, which is species. So he chose the last 2 levels, the genus and the species. So that's 2 names. And that's what he used then to scientifically name organisms. Now, Linnaeus chose Latin. So a lot of these scientific names sound Latin. Some of them were actually from Latin. Now they just a lot of them will Latinize them. So they'll turn it into so it sounds Latin even though it may not be. But we're going to look at why, because he was very wise. Now remember, this was back in 1753 or prior to that when he was writing the book. And why did he choose Latin? Well, he chose Latin for 3 reasons. It is unchanging. It's what we call a dead language, meaning that it is no longer spoken, which is a good thing. If a language is being spoken, it changes over time. We're going to look at just English. And you think that, it's changed a lot from King James. the King James Bible, where they have the these and the thous. Well, I'm going to show you even older than that, which was English. It's very descriptive, which is what Latin and a lot of these root words, they pick them because of their meaning. And then Latin is a root of many of our modern languages. So if you go look in a dictionary and you look at a lot of our words, you'll see they go back to Latin and Greek, but a Latin is a lot of them. And that's true with Spanish, that's true with German, that's true with a lot of the languages. So let's look at this Latin. Why it's important, the unchanging part. This is the Canterbury Tales written in Middle English. So see if you recognize any of that. By the way, I had to memorize this when I was in high school, my senior year. I do not know why the teacher made us memorize something in Middle English, because I didn't even know what I was memorizing. It goes, Juan the Opera with his shorter sota, the drought of March hath percé to the rota, and ba that every vine in swish le cure which vet tout engendred is the fleur. One Zephyrus ate with his sweet breath, and spirit hath, and every Holden hath the tended crumpets of the younger Sona. Now I forget how many lines we had to memorize, but that's what I do remember. Now look at the translation. Juan the Opera with his shorter sota is when April with its sweet-smelling showers. The drought of March hath percé to the rota, has pierced the drought of March to the root. Now look at how much it's changed from Middle English when the Canterbury Tales were written to now. Now I want to show you Old English. I never had to memorize this. It's a good thing because I have no idea how to talk it. But here is Beowulf. That is written in Old English. Doesn't even look English to me. Looks more like it might have some German or something in it. But you can see now how when a language is spoken, over time it changes. So he was very wise to pick Latin for the scientific names so that they wouldn't change, so that scientists from way back to present time can know what an organism is by using its scientific name. So let's look at these scientific names. Binomial nomenclature is the system. That's what it's called. It's made up of two names, the last two levels of his classification, genus and species. Species, remember, is a group of organisms that have similar traits and they are able to produce fertile offspring. Like all dogs are in the same species, all humans are in the same species, all horses, all sheep. Genus, though, has more organisms in it. So it actually came from the Greek word, which means the genosi, or however you say genos, or genos, which means race or kind. So it's a group of similar species. So there's more than one species together in the genus. So it's similar to our name in that, let's take our two names. My first name's Peggy, last name's Stanley. So in my family, there were 4 kids and mom and dad. So the Stanley household actually had 6 people that it referred to. And if you look at aunts and uncles and all that, it had a lot more. But at my particular residence where we were living, there were 6 Stanleys. But when you said Peggy Stanley, you were narrowing it down to that one Stanley. So that's like genus being the Stanley name, and then species being the first name. Only when you write it as a scientific name, they write it the other way around. The first name is the genus, and the second name is the species. Notice in looking at the name Canis familiaris, which is the scientific name for dogs, the genera is, or that's plural for genus, it is the one that has a lot more organisms in it. And then species would get to one particular. So there's more than just dogs in Canis, such as there's wolves, coyotes, those are Canis. And then familiaris is just the dogs. So they write the Canis, which is the genus first. So it would be like being called Stanley Peggy instead of Peggy Stanley. Notice what's different about the way the two words are written. The Canis is capitalized, the Familiaris is not. So the Canis is always capitalized because it's the genus and it's first, and the second is always not capitalized, and that's the species. And that's its specific name. So the species in the scientific name, so going back to Familiaris, the species is referred to as the specific epithet, meaning that narrows it down to one specific kind of organism. Not dogs, coyotes, and wolves, but just dogs, because it's Familiaris. And just like Homo sapiens, sapiens is just human beings. So that's the specific, I can't say it, specific epithet. Epithet. That's hard to say too, epithet. Now look at these scientific names. And just by looking at those, can you tell me something about these organisms? Give you a minute to think. Well, did you catch that they all have the same genus? So that must mean they're pretty similar in some respects because they're all in the same genus. Look at that name, Californicus. That is a California Latinized. So they are probably found in California. Nelson was probably named after a person. Spinatus, that was probably, maybe it looked spiny or looked like it had spines on it. Well, this is where these names go, the organisms that they go with, right here. So when we see that they're in the same genus, we know that they have a lot of similarities. But they're written in a different species because there's something specific about them that puts them in that species. Oops. So you need to know the genus is the classification group that contains similarly closely related organisms like these three. Species often describes a distinct feature of that organism, such as where it lives, like Californicus, or its appearance, like the Spinatus. Here's R. Make sure you know our scientific name. Homo is the genus that we are in. Sapiens is the species. So all human beings are referred to scientifically as Homo sapiens. Now look at this creature. Cute frog. The scientist who first described the Central American red-eyed tree frog thought it was especially pretty with its pea-green back, its chrome yellow and bright blue lantern patterns on its sides, and the bright orange feet that it had, and the vermilion eyes. So he named it. I'm not sure how you say that scientific name. You guys that took Latin last year, you can pronounce it for me. The beautiful wood nymph is what it means. So they're picking words that have some characteristics to the organism. Here's another example of a scientific name, and this is for the sunflower. Here's what you need to know about a scientific name. You need to recognize it. You need to know how you would write it. You need to know that the genus is always capitalized and it comes first. You need to know that the species always comes second and is not. Now, you may not have noticed that it's italicized, but it is. And you always, in any book, when you see an italics word, it means it's from a foreign language. So it's foreign. Now, you can't write in italics. So if you had to write down a scientific name, you would write the genus first and capitalize it. You would write the species second and not capitalize it. And you would underline it. And that's what we do when we write. The scientific name was given to an organism by the first person to publish a description of that organism. So they got the honor. So that's why sometimes they named them after their pets, named them after people like the Nelson. Here's genus is the Felis, the feline. See, that's where they get felines for cat. It's actually from the genus name Felis. Felis shares characteristics such as sharp claws, retractable claws, behaviors such as hunting other animals. So there's lots of different types of cats in the Felis. But when you get down to their specific name, here's the puma, Felis concorla, or color. The concorla means the same color. Notice the shade of the fur on it. It's mostly the same color all over. Whereas when you look at this cat, it's got more of a marbled look, so it was named a scientific name, which means marbled. And then Felis means cat. And then we have the domesticus. That's where they've taken a name, ignore the telephone ringing, Felis domesticus. That's a domesticated cat. That's when they took cats and taken them in the house. So domesticus means of the house. So cat of the house. Scientific name, every organism has one and only one scientific name. Important to know. A single scientific name applies to only one species. So they can't have two scientific names. Sometimes scientific names are called Latin names, but they're not actually Latin, like the Californicus, the domesticus. The term that makes up the scientific name can be from any language. However, they must conform to Latin and grammar. Let me shut my phone off. I'm sorry, I'm having trouble shutting the phone off. All right, so they Latinize them. People don't always agree, so they actually have taxonomists who meet, international committees. They meet periodically. They go over the classification system. Why? First of all, we're finding new organisms. With the more technology we get, better microscopes can find more organisms. Go to deeper parts of oceans and go to other places. And also because sometimes we find out more information about an organism, and so therefore the name has to change because it may not apply anymore. So they make those kinds of decisions. So do realize that scientific names can be changed, but they have to be changed through these international committees. Now I want to go over the difference between biblical kind and species. Now Linnaeus was a Christian, so when he did organize, he tried to do that according to biblical kinds. But realize this has been done by all kinds of humans now, and even evolutionists and atheists and everybody else. So biblical kind and species are not the same. Biblical kind is what God did when he grouped the organisms. God's the one that said everything reproduces after its own kind. So that was established by God. So when was that established? Way back in creation. Species was first established by Linnaeus. And so that began then in 1753 with his first publication of his book. So it was established by man. There are some requirements to be a biblical kind. There's two. They can reproduce with other organisms in their kind, and they produce offspring that look like themselves. And a good example would be wolves, coyotes, and dogs. They are of the same biblical kind, and they are in the same genus. They can reproduce, even though they're in different species. They do reproduce. And those pups, when they grow up, even though they may be half wolf and half dog, they too can have pups. So they can reproduce. A good example of not being the same would be a horse and a donkey. When a horse and a donkey, I think it's a female horse or a female donkey, I forget which is which, but they have a mule. And when they do, that mule cannot reproduce. It's actually sterile. So we know that the mule came from two organisms that were similar, but obviously they're not the same biblical kind because their offspring sterile and cannot reproduce. The last thing in your book they talk about is some tools that are used to help to classify. So if you had a bunch of leaves, or you were out walking and saw all these flowers, or you had all kinds of beetles and you were trying to find out which one, they use these three things: field guides, dichotomous keys, and the cladogram is actually really just used by evolutionists, not by creationists. But the field guides and dichotomous keys, and we're going to get some practice with the dichotomous keys in class. A field guide, you can buy them anywhere. Most, they have descriptions and illustrations. I have several about birds because I'm interested in birds. I have some at school about trees, and I'll remember to bring those so I can show them to you. A dichotomous key is probably not as familiar with, and it's a series of descriptions that are arranged in pairs, and they help to identify. So you see the objects over here on the left, and if you were to use a dichotomous key, you would pick one of those objects, and you would always start with pair number 1. You read the 2 descriptions, and you see which one fits a description of the object that you're trying to classify. And so if it was a long tubular object, you would follow it, and you would go to then the description number 2. If it was short, non-tubular, then you would go to 4. And let's say it was the tubular, so you go to 2 and you read those, and eventually you figure out what it is. Here's another, of course it's a little hard to read, but this is a dichotomous key put out by Wards of different microorganisms, things you find in the water, and they're microscopic. And you use this to help identify them. Now, a cladogram, what it is, it's a branched diagram. Let me get it up here so you can see it. It's a branched diagram that shows the relationships among organisms, including common ancestors. So that's where the evolution comes in. And of course, you can see how they're putting common ancestors together. Of course, we know we don't have common ancestors. We have a common creator. That's what we have. All right, have a good night.